That's what I'm feeling about this power supply, man.
Yeah, it is wearing out its welcome.
Yeah. So we got to make some progress today, or else I'm just going to start ordering Meanwhile supplies, and we're going to rebuild it in the next one. I am starting to think that, you know, so much stuff looks like it's working fine on the regulator boards that maybe some of the logic on the backplane could be holding us up. I say backplane, I don't mean PC backplane, I don't mean computer backplane, I mean the power supply backplane.
Yeah, I know what you meant.
Trying to find a decent screwdriver here. There we go. Because we've kind of been all up and down the regulator boards. I mean, there could very much so be a fault on these, but like we have not been lucky chasing that down in any way, shape, or form.
Yeah, I think if I remember right, where we left off last time is that whatever was supposed to be enabling the output drivers was either never coming up or being held and shut down, and we were trying to figure out which of those two cases it was.
Yeah. Yep. That's I think kind of exactly where we were. Let me get the. So yeah, and we were kind of running into the issue of that little bit of circuitry that's like the overload circuitry that's preventing the regulators from starting up is very different on the 980A versus the 980B. Everything else seems to be very similar, but that particular part is like dramatically different.
Yeah, like the little relay we couldn't even find on the schematic or parts list at all.
Oh wow, the fuses aren't fuses, they're just wires. So there's like one thing that I didn't check when we had this backplane piece out was there's fuses on here. And I never checked the fuses because I didn't recognize it. And they're not fuses, actually. It looks like they're just like jumper wires. And apparently 5 amps through that jumper wire will blow it.
They're actually 30 gauge wire, and they're supposed to blow at 10.
Okay.
According to the B, anyway. I would expect the same.
Visual alert when the smoke comes out.
Yeah. Yeah, I think we need to pull, I think I'm going to pull this backplane out one more time. I mean, I can't get it all the way out, but I can get it kind of loose and accessible. And I'm just going to go through and check the fuse wires because I can see that 2 of them are like bent over and crushed, which is not great. And then I might also use my multimeter and see if I can do a diode check on these 4 rectifier diodes.
Rectifier, I don't even know her.
Yeah. Yeah, so let's try that. Yeah, these 2 come from the backside, if I remember right. Because if we've got, like if the regulator boards are fine, and we've got our clock oscillator oscillating, I mean, and we've got our plus 35 going in because we're seeing that get regulated down to like plus 21, and we're seeing the VREF come up. There could still also be a fault on the backplane that's like pulling the whole thing into crowbar, or one of the fuses is popped, so we're not getting anything out. Or it's, I don't know enough about the total design here to know exactly what on the backplane would prevent the regulators from coming up, but I suspect there's something on there. And then if everything on here checks out, I was thinking we would approach the issue of the regulator getting shut down from the different direction. So we were trying to follow it from the output of the regulator back, and that just leads us into the nightmare fuel. So instead, I think we look at the pinout of the backplane, because I'm pretty sure the backplane is the same on the 960 and the 980. So I was thinking instead we just look at that pinout and we look at what signals, are going to be preventing the oscillator from coming up, or preventing the regulators from coming up, and then we start probing that signal and working our way backwards from there. And then if it all goes sideways, we take a moment to try and figure out how we can plug mean-well supplies into this backplane and go from there. All right, I think I'm gonna pull one of these big capacitors free.
Yeah, at this point, it might be easiest to just cut your losses and slap some mean wells in there.
Yeah, that's kind of what today's journey is all about. We're gonna give it one more chance to not be atrocious. And then, if by the end of tonight we've made absolutely zero progress, we still have absolutely no clue what's going on, I think we'll sit down and we'll go, okay, if we were to just replace everything with mean wells, what would that entail? And we'll take a look at all the different signals that we got to recreate. Oh, right, this was the one that had a stuck. I couldn't undo that one if I remember. I'll leave it loose because I can kind of swing it out of the way. The two jumper fuses that I'm slightly worried about are kind of right in between a bunch of the capacitors. That's why I'm trying to get one of the caps out here. Oh, and there was something bolted there that isn't bolted in. What is that? What went in there?
Is this the part where we find the bolt floating around somewhere between the case and...
Oh, no, that was just the clamp for one of the caps.
Oh, all right.
Yeah, I didn't put those clamps back in because I didn't want to deal with them. Let's get this big boy out of the way. So, just throwing screws around here. No idea where that lock washer went. Oh, there it is. All right. All right, we've got pretty decent access to stuff now. I think these two were the same. 22,015. 22,015. Yeah, those two were the same. Yeah. So here, I'll take a picture of my concern with my fuse/jumper wires. We might actually have one of them shorting out. I should have noticed this earlier.
Way to find out would be to measure it before you move it.
That's what I'm doing right now.
Oh, that looks gross.
Yeah, no, it's not great. Yeah, I don't think those are shorted, but... Or they are. There's 0.3 ohms difference there. So that may be the problem. We may just have F3 and F4 shorted to each other. It certainly looks like they are.
Yeah, there also looks like the one that's closer to the right side of the picture, there's an outline around that pad that looks like the pad could be lifted.
No, the pads are fine. I'm looking at those kind of up close right now. The pads are okay. Yeah, but we definitely had F3 and F4 touching. I say that, although I've moved them away and I'm still getting point. Oh no, now I think capacitors may be charging up. No, I'm still getting 0.3 ohms. So why would I have a dead short between F3 and F4?
What's on the other end of the white wires?
The SCR, no, the two diodes. Oh, that broke. That's fun.
Okay, if you measure between, like,
Yeah,
where the lettering...
Fix that.
If you measure from between where the lettering F3 appears and then the far side of one of those white wires, do you see the same resistance or more?
Hang on a sec. Endora Fox, thank you so much for the gifted subs, man. That's awesome. Thank you, dude. Endora Fox out here crushing it. Yeah. All right. Let me pull up the schematic for this backplane here. Just try to wrap my head around what it is that we're looking at.
Yeah, what I'm curious about is, can we determine if the short is on the near side of these white wires or the far side of these white wires? I would expect that if it's on the near side, if you measured from like the F3 letter to the far side of one of the white wires, you would see a higher resistance because you're transiting the cable. But I don't know that your meter would be good enough to see it.
Ooh, also, looking at the schematic, F3 and F4 are connected to each other via the winding of the transformer.
Oh, all right.
So F4 goes straight into one winding, F3 comes straight out of another winding. So that's, I mean, they definitely look like they were touching originally, but that may not be our issue. And the like super low resistance that I'm seeing is likely due to me measuring the winding of the transformer. Maybe I can unplug that. Although those, yeah, there we go. I can get you out of the way, but I do think that the transformer is still going through those, let's see here. Well, let's just measure that now. No, I'm still getting 0.3 ohms or whatnot, because I think two windings of the transformer are coming straight to those white wires that are going through the diodes, and those are all soldered in place. I can't remove those. God, this thing looks like garbage. All right, let's at least do a diode check on the big rectifier up here. Well, none of them are shorted. But I mean, they're in circuit, so there's only so much you can determine in circuit. Ooh, that one I can't measure through. Yeah, there it is, 0.5. Oh, you guys can't see. You guys are just like looking at my laptop screen. There we go. All right. Well, I mean, I broke a ground connection on this thing, but that was not broken until I was twisting this thing around in weird directions. So that's not the primary issue. Well, I mean, one of these diodes looks not great, but it didn't measure open or shorted, I don't think. So I think what we do now is we plug this thing back in without the regulator cards into it, and we try to see if we can find plus and minus 35 volt AC.
Yeah, the only other thing I can see that concerns me is that trace that's on the right side immediately before the mounting hole for the capacitor lug. Looks like a freaking ghost. Is that a trace on the opposite side, or is it just blasted, or what? What's going on there?
It's just
It might be
crappy.
just the exposure washing out. Yeah, all right.
Although I don't know where that trace goes. I was thinking it went to the plug here because that's where it looks like it goes, but maybe not. I think it might. Oh, it goes all the way over to here, I bet. Yeah.
As long as it still has continuity, I guess.
Yeah, I've got continuity to that via. Oh, wait. Well, hang on. I'm in diode mode. But, I mean, that showed a connection.
Yeah.
So that via that goes to the opposite side, I've got 0.2 ohms across it. I think it's just, I mean, the trace is there. I think it's just got scale and grossness on top of it.
Yeah. I think it's the exposure is washing out the part I'm looking at, and it makes it look like it just got eaten away, and I'm looking at the board material underneath it. But I don't think that's the case. I think it's crap over the top now that I'm looking at it differently.
Yeah. I mean, what I need to do is run over this thing with a Scotch-Brite. But I don't think that would make much of a difference. I certainly don't think that that's our problem. Like, running over it with a Scotch-Brite will fix the issue. All right, let me get a new lug for J3 here because I broke it. And then let me get the capacitors back in place. Yeah, and so I think pretty much all this thing's producing plus and minus 35 volt AC, and then we have a plus 35 DC and like a minus 8 DC. So I think without the regulator cards in, we should plug in and see if we can find all of those voltages. And if we can, then we can be, moderately confident that the backplane is at least mostly doing what it's supposed to be doing.
Have confidence.
Yeah, this whole thing is pretty close to getting on the chopping block today. And I think we can, if we want to go the Meanwell route, we can just like take all the components off of the backplane here and then just run wires directly from the Meanwells to the backplane that are supposed to feed all the different voltages that go to the CPU.
Yeah, the only thing that might get shady is if there's any weird special snowflake sequencing that has to be done on startup.
Yeah.
IBM loves doing that kind of crap.
Yeah, and there's a lot of weird voltages as well, but I don't know how many of those are like, sometimes you've got voltages that are like left over from core memory or whatnot, right? And so if you don't have core memory, those voltages just don't do anything, but your power supply is still supplying them in case you had a core memory board that you put in. But since I don't have a core memory board, like, I don't see what's stopping us from just like, ignoring those voltages essentially. But I don't know for sure. We'll have to, when we get to that point, we'll have to like stop and take a moment to figure it out. I'm pretty sure that you are minus. I said out. So there we go. So that goes like you. Like I know what was it? The Nova? No, not the Nova. The PDP-11 maybe. They have like a core memory voltage that isn't used by the
not used by semiconductor. Yeah, it's not used by semiconductor RAM. And on some machines, if you didn't have core, or if you had core memory, you had one set of voltage regulators installed, and if you had semiconductor memory, you had a different set of regulators involved, because you wouldn't need the special weird core memory voltage, but you would need more 5 volts or 12 or negative 12 or something like that. And so you would change out the regulator that was the core memory for the regulator for semiconductor memory. You couldn't mix and match them. And there were people that were doing really weird crap, like having the low memory be core, and then the idea being that their supervisor or whatever could take the power fail trap and then reload the semiconductor memory, that kind of crap. No.
That's a smart way of doing it.
Yeah.
One of my screws here is stripped. I gotta get a new screw. It pulled,
another thing that you could see more in PDP-8s than PDP-11s, but very common in PDP-8s, you had core emulator boards that would have a whole bunch of SRAM on them and then a battery. That way it emulated core.
This power supply is already set up for an external battery.
Yeah. I mean, not that we're going to do that.
Looking at the B drawings, there is a power supply OK signal that goes to the CPU.
Yeah, I mean, that's something that we could probably replicate. I mean, I know we can replicate it. It's been replicated on other machines.
But I don't see any sign that there's anything outside of the regulator boards themselves that do both overcurrent and overvoltage protection. That looks to be totally contained within the plus 5 volt regulator card.
All right, we're going to get a little janky here.
It's possible to get more janky.
Yeah, I mean, it's not like I'm going to make the thing worse. Oh, you're a little shorter. Let's try you.
Well, the good news, it's TI, so they should all be Imperial thread screws.
Yeah, I've got a couple of screws. I've got threads that'll fit. The problem that I'm running into is finding a screw that's short enough that doesn't bottom out.
You don't have a pair of crimpers that have a bolt cutter in them?
Well, I don't want to go cutting bolts when I can just find one that does actually fit, like that one. All right. I do need a pair of wire crimpers, though. And a new terminal lug, because I broke the grounding one off.
Now,
that was
Schrodinger's
that
power
that's
supply would be. Oh, I'm sorry. I talked over whoever that was.
I was just asking if the wire he broke was a lugged on or soldered on wire.
Oh no, it's like an actual like blade connector.
That should be easier.
Yeah, I don't think I have a blade connector that'll fit. Maybe one of these guys will.
You got a ring connector you can slice into a blade connector?
Well, I got ring connectors that I can bolt in as opposed to.
Oh, it's passed on style?
Yeah. So it's got a blade lug that is bolted to the board, and then you have the like female part that goes over that blade that comes from the wire, and the wire's very thick is the problem that I'm currently looking at. So I think I need a really fat lug here to fit over the wire. But if it's going to be a fat lug, what I'm going to have to do is I don't have one that'll go into that blade. So I'm just going to have to unscrew that blade and then just screw the new wire onto that section, which is fine. I can do that. Oof. Break loose. There you go.
Just I didn't look back at the old screen. Do we know this is strapped right for our line voltage?
That was another thing I was going to check. I'm pretty sure it is because it's got a big sticker right here that says 115 volts. So
Okay.
unless it was purchased as 115 volts and then somebody later modified it for a different line voltage, but left the like 115 volt plug on it, because it's got, you know, it just plugs into like the standard wall outlet, right? It would have to be like extraordinarily unlucky for it to be like wired up for 220 volt. I don't even
Well,
think
if
you
you're
can.
getting 35 off the secondary, you're pretty much going to be right. There is a note that they do shut down for low line voltage.
Okay. Come on, crimp.
There's a
Uncrimp.
set of tables.
Don't make me cut and strip. I don't want to cut and strip. You're going to make me cut and strip, aren't you? Yeah, I saw that page that had like the 4 ways to set it up for the different line voltages that it supports. Oh, come on, let loose. It's just going to be 30 minutes of me fighting with one wire. Yeah, all right. I don't think I'm going to be able to get that to break free, so we're just going to cut it, strip it. It's just going to be a little bit shorter than it used to be. And then I need this big guy here. Strip just a little bit more off of it.
So that should be one of the transformer wires, if I'm guessing right.
Yeah, I think so. It's coming from the transformer, but it just looks like it goes to the big ground plane. So it's probably like the center tap or whatever.
What color is it?
orange-ish. It's like a cloth type wire, which is really kind of interesting.
Probably white.
Oh, it's definitely not white, unless it had a white coating on the outside of it that has flaked off.
It used to be white.
What lug does it go to?
J3.
That would be your white.
Yeah.
It's certainly not
That
white
would be
anymore.
that would be your common out of your full wave rectifiers. That's your center tap.
Okay. Yeah, I was gonna say that my guess was that it was the center tap.
Yeah. So that's your logic common.
Yeah, it wasn't broken
So you don't
before.
call-
Like I broke it just now doing this. So that was not our problem, although it is now a problem. And I may need a longer screw for that. No, I think I can make that work. All right. All right. All right. I guess we'll slide this thing back in. This comes out like you. There you go. All right. Let me get this thing screwed back together. And then we'll, I guess, plug it in and see if we can find what it's supposed to produce without the regulator boards. Like if we're missing, I don't know, like a negative 35, I was thinking, because I don't remember ever seeing a negative 35. We saw the plus 35. But there's a plus and minus 35 AC, and I don't know what that minus 35 AC is used for.
Looks like it goes straight to the CPU card for something. It goes straight into the backplane.
Oh, it doesn't touch any of the regulators?
Unless E9, E10 jumper is jump.
I don't know where the E9, E10 jumper is.
They're on that backplane card you've got out somewhere. I'm betting they're a little turret post or something.
No, there's no turret posts on this thing.
Okay, well, there's just two pads labeled E9 and E10.
All right. Did I get you too tight, maybe? That one is now in.
Yeah, it looks like the plus and minus 35 are fused and go into the system backplane for some reason.
For
But they don't look like
TI
they should
reasons.
affect the 5 volt.
I wonder if the AC voltages was what we were talking about, where that's like something core memory related, maybe.
Not unless it was being regulated to 35 DC somewhere. It could also be like the PDP-11, a line time clock.
That's true.
Fuses for an LTC.
They were serious about their line time clocks.
Definitely don't need that much voltage for a line time clock, though.
Well,
No,
the
you don't.
PNP11 uses 24.
What uses 24?
The 1173, it has a 24 volt line time clock.
Wow.
Yeah.
Yeah, and then a full wave bridge rectifier and a drop down.
All right.
Looks like pins 70 and 71 on the connector are optional plus or minus 35 to the aux mem and reference card, but are not normally connected unless you jumper 9, 10, 5, 6 together.
So the big thing that we're worried about, like what on, like the bigger question is like what on the backplane could prevent the regulators from starting up? Like, is there something on here that's being generated on here that if it's not generated is going to prevent the regulators from starting up?
Well, that's where I was looking at the LC ground plane for the logic common, which
Yeah.
gets jumpered to ground at the motherboard.
Yeah, but there's the 27 ohm resistors. There are plenty big or small.
Those are not on the LC, though.
Yes, they are. There's a 27 ohm on the L, 7 ohm on the sense.
I missed the LC.
They're
Which
right next
board
to
is
each other
that?
on the schematic.
Which
DC,
board?
I think it's the 5 volt regulator board.
XA2.
Yeah, it's the resistors are on the regulator card.
Ooh.
I mean, I've got the battery
You
is
can look at-
off. Like, I'm trying to think, it's like, is there maybe supposed to be like a jumper block that you're supposed to plug into the back if you don't have a battery?
No,
Not that I remember.
battery is just optional.
Yeah. Oh,
And for reference, I
Right.
used to have a half dozen of these running visuals on flight simulators.
Yeah.
980s?
TI-980B, Evans and Sutherland's original host computer for their first digital image generators.
Did
Oh.
the 980B have a power switch? Because it still drives me up the dang wall that there isn't a power switch on the front of this thing.
Not on the front. I think it was on the back of the chassis.
Just the circuit breaker.
Yeah. I hate that design. Like, you should have a power switch that you don't have to walk around to the back of the machine to turn off.
Well, you normally never use.
All right, well, let's see if we made it better or worse. We'll plug the rectifier cards back in, turn it on, see if we've got our 5 volts.
So page 6-50 on the schematic, where it jumps all the plus 5s and all the LCs together. The LC sense and the 5 volt sense each have 27 ohm.
6-50.
Top right hand
Which-
corner.
Which 6-50?
Yep.
Top right hand corner.
You see where all the outputs are jumpered together?
Right.
Just to the left of that, you can see your 227 ohm resist.
Right, that's sense ground and plus 5 volt sense, but
That's
not
all you
NC.
need.
Now
Because
you
with-
need NC is separate.
I do see what you're saying, though. It does look like there is a connection between 1, 2, and the ground pins made via the backplane.
nope. That 27 ohm resistor does the same thing. It just gets shunted by the backplane when the backplane's connected because the wires should
Right.
be lower resistance than
Oh,
27
I got
ohm.
you. Yeah, I got
But
it.
that's the main ground, not the LC ground.
There is no main ground. LC is the ground.
Now they're
That's
kept
logic
separate.
common.
The logic common, right? But if you look at the shall we say motherboard that has all the capacitors and diodes and rectifiers, if you look at the schematic there, you'll see that LC comes in on pins 1 and 2 and 35, 36. And gets wired to ground from there.
That's only a safety ground.
Now, I beg to differ. I think they kept it that way so it wouldn't power up without being plugged into the motherboard.
Nope. I guarantee you there's no.
Well, it's behaving differently. I can hear it. I can hear the regulator clicking, but also on the 5 volt, we've got like 4 volts now.
Well, maybe your wire you broke was down to 1 strand and not working well.
I don't know.
Check
Let's.
the voltage. You can check the voltage on LC and see where it sits. That would give you a good idea as to what the logic is.
Well, yeah. And while I was checking the 5 volt, the main 5 volt out.
5 volt. Yeah.
Yeah. If I want to check LC, think that's you, which is at 5 volts. So like our actual logic voltage, the 5 volts that drives all the logic on the boards and whatnot is at 5 volts. But that's always been there.
Right. That's 5 volts aux.
Yeah,
But
that's
the
always been
common-
fine.
5 volts aux is only used to run the power supply itself.
Right. But
5
the
volt
LC,
main. 5 volt main is what runs the computer.
right. But the ground, the LC, the logic common, doesn't have a source of a common.
Okay. Somebody came out and needed my attention. So what happened when it was powered up?
It's behaving slightly differently, but I don't think in a good way. I just think it's behaving slightly differently.
Oh, okay.
But I am going to put some. I'm going to put some load on it and see what that does.
Oh, okay.
So I'm going to put load on it by just going full send because I'm sick of this thing.
I think what you're seeing is where it says LC on the backplane schematic. That's a bad label. That's actually LC Sense.
Actually, that is the LC sense on the far right side of that is actually the main ground, 5 volt ground. That's the sense ground, not LC. If you look up further on that same schematic, I was looking at that as well. Sense ground is labeled up further up near the boards. I think it was mislabeled down towards the motherboard.
All right, let's check these again with a load on it, see what happens here. That one's still fine.
No
That one's
lights.
at 21. Yeah, so our 5 volt aux is still at 5 volts. Our 21 volts is at 21.6. There's another 5 volt. I forget what that is. 5 volt sense maybe. That's at 4.98. We've got a plus 39 over there, but my output ground and output 5 volts is at 0. So it's like it's going into crowbar. When I flip the switch, I can see it. Well, not now. The first time I did, I saw it bump up to about half a volt, and then it walked itself down to 0.
Well, this power.
You cut out there. All I got was this power.
This power supply does not have a crowbar. The crowbar on the 5 volt supply is the big SCR on the backplane, which shorts out the input and blows the back panel fuse.
Yeah.
Yeah.
So there's nothing that can crowbar per se this power supply.
Well, that is the crowbar. Depends upon what voltage it's sensing is wrong, and it'll crowbar.
Well, there's individual crowbars on the low voltage supplies. The +5 fires the SCR
Okay.
on the back plane and shorts output or input DC to ground through that fuse.
All right. So something is telling this thing not to start up, right?
Yeah.
So right now, what we know is that there's a difference in that overload circuit, right? So let's just black box that overload circuit for the moment and say, okay, what's the input to that overload circuit that is telling it, hey, something's wrong, right? So there's a couple of inputs coming via the backplane. One of them is all regulators up, and that does go straight into the 980 overload circuit control. So it's possible that all regulators up is a signal that exists on this power supply.
SCR drive is the one we're looking at.
So SCR drive triggers the crowbar.
The crowbar.
And since, you know, we haven't exploded F1, which fuse would it blow? F1?
It would blow the external 15 amp F1 that's in a fuse holder in the sheet metal.
Yeah. Well, it's now in a different fuse holder, but we haven't blown that.
So we're not finding.
Yeah, so SCR drive is not something that we're potentially worried about here.
So
Let me double check that we haven't blown that.
It's more likely the actual 5 volt regulator isn't going into regulation, either because of ACOK or reference voltage into the chopper, which drives the switcher.
Yeah, that's fine. So yeah,
Well,
we're never seeing the switchers start, right? The switchers aren't running. The base to those transistors are never turning on. We followed that backwards a long ways, all the way until we got into kind of what we're assuming is the overload circuit. So the overload circuit is never enabling the transistors that enable the bases of the primary regulators, right? So the regulators are never kicking off, which means we're never getting our +5 volts out, which is fine. But the logic that's going to the transistors that would turn those on is coming from an LSO3 and an LSO9, and it's quite complex. And I think it also goes through a relay, which is involved in the middle of that. I'm pretty sure that the LSO3s and the 09, I'm pretty sure all of our 7400 series logic is fine because we were seeing signals that made sense on the output for the inputs that those particular gates were seeing. So it's further back. Now we're getting into the black box portion of it, right? But something has to be telling that black box, hey, don't turn on.
So the regulator is a pair of comparators.
You keep cutting out, by the way. I only got comp out of you. There's a pair of comp.
The regulator is a pair of analog comparators.
Yes.
And if the comparators were bad, that's exactly what you would see.
Were you here last weekend, by the way?
No, I was
last
not.
Friday. Oh, we checked all that. Yeah, we checked all that. We're good. The inputs to the comparators are showing that the comparator is doing what it's supposed to do. So
okay, so
not an issue there.
Overload circuit,
we're further back from that.
The overload circuit is just the inductor on the output of the regulator, and the voltage across that inductor is fed back into the comparator.
Yeah. No, I get what you're saying. The overload circuit is different on the 980A than it is from the 960B and 980B. So this is where we're getting into the black box that I keep referring to. And when I say different, I mean different. Like the flip-flop doesn't exist. There's a relay in the middle of it. It is wildly different. So that's why we got to black box it and just go, okay, what would be a signal from the backplane that would tell it not to come up?
Yeah, my point is,
yeah, Timber 454. This is why I like linear power supplies too. They're way easier.
Yeah, as far as I can tell, there's no signals on the backplane reference to overload or overvoltage.
With the exception of all regulators up.
That's an output.
But it's an input into the overload circuit of the 980B.
And it's an analog output from the miscellaneous regulator card that says its 5 and 12 volt regulators are okay.
Yes. So that's one signal that I don't think we've checked. And it is an input into this black box overload thing, overload circuit, right?
I just had a thought.
Yeah, go ahead. Go ahead.
Okay, is it possible that during startup there is something that fakes the all regulators up to get the initial pulse to start them?
The all regulators up is for linear regulators on the aux card.
So it's not the main 5 volt one?
Nope.
No.
Oh, all right.
But if the all regulators up signal does not make it to the main 5 volt card, then the main 5 volt card doesn't start up. Is my thinking.
You should be able to look at that easy enough. You should be able to see it on the connector or on the aux regulator card.
Yeah, I'm just trying to figure out what voltages it's supposed to be at.
I think it's 0 and 5. It's just a TTL signal.
Maybe. Yeah, so it is. It's 5 volt aux, and it's controlled by Q36. And so if Q36 is on, that's going to pull all reg up down. If Q36 is off, all reg up should be pulled up to 5 volts by the 4.7K. So I can check pins 53 and 54. Let me figure out what pins those are. And it should be 5 volts. So logic common is 49, 50, 51, and 52. And then, right, what What pin number? What pin orders am I in? Let's see. The 5-volt output is on the left side here. So that's going to be 1 and 2 all the way over here. So we've got 4950, 51 and 52 is our logic common here. So if I check that as my ground, and then all reg up should be on 53, 54 right next to it. So if I check U to U, that should be 5 volts when I flip the power switch on here. Helps if I plug it into the wall, huh? All right, let's try that again. Let it common. This should be 5 volts. It is 4.9 volts. Boy, I can hear the regulator clicking. Tick, 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 tick. It's like what it was doing when we had that bad transistor last time.
What voltage do you get on 5152?
What is 50? What
From
is
between that and the main, that's LC.
Yeah, so what, LC 5152 to what?
To the main 5-volt ground.
Okay. That would be like you get like 4.02 volts, I think.
Yeah, that's not a good sign.
Or 0.05 volts. Probably that one.
5152.
Depends on which one's ground and which one's 5 volts. Hang on, I probably counted wrong. I probably got my planes backwards. So 1, 2, 3, 4, 5, 6. 5, 6 is ground or plus 5 volts? 5, 6 is ground. Right? Yeah. So that's plus 5 volts. So if I do U to U.
And
Yeah, that's at like 4 volts. Hang on. Yeah. 1 and 2, 3 and 4, 5 and 6.
5 and 6 is plus 5.
All right, I'm showing that at negative 4 volts, weirdly.
Yeah, go from 4, 5. No, 3, 4. Let's see. 1, 2, 3, 4, 5, 6. Yeah, that's ground.
Yeah, 5, 6. That's showing me as negative. So if I've got my positive probe on 5 and 6 and my negative probe on logic common, I'm showing negative 4 volts.
Yeah, that needs to be 0. That's what I was saying about that logic common being actually tied to ground on the motherboard. It makes the supply float so it won't come up.
I mean, I can plug it in and check it again. I can plug it into like the actual backplane.
Yeah.
Check things in situ here.
Why they did that is beyond me, because there's no reason for keeping the supply from coming up while it's unplugged from the motherboard or from the backplane.
Well, maybe the regulator doesn't like to regulate without a load or something.
No, because if you read through their 50 or 60 step troubleshooting guide, they have you pull the power supply out and turn it on and off and measure all sorts of things.
Yeah, that doesn't make sense.
Well, if you go back to the chapter,
your logic common has to be at ground potential for the logic to work. And if LC isn't at ground potential, you're not going to get much logic action.
Yeah, that's at 0 volts now.
Yeah.
But then again, so is the 5-volt rail.
Well, yeah, we expect that though.
But the 5-volt, I think
But
that's
there's
since
still problems.
21 volt is fine, 5-volt aux is fine, 35 volts is present. It's actually at 40 volts now. So the ICs, yeah, the ICs are all seeing their appropriate 5 volts. Now I don't think the like I can't hear anything.
Clicking anymore?
Yeah, well, the clicking goes away, but also it's not like before. I was hearing it start up and shut down. I was hearing the oscillator start up and shut down. Right. I mean, I couldn't hear it when it was running because it was too high of a frequency, but I could hear the transition between on and off, and I don't hear that transition when it's plugged in anymore. But
Yeah.
that doesn't mean anything. I mean, that could be what it's supposed to do. Still feel like there should be a power switch somewhere other than the one on the dang back. But all I got is a panel lock and unlock. And nothing else on the front. I mean, I got a reset. Unless you got to hit like a reset to start it.
There's no signal name either that on the backplane that indicates power on.
Yeah. So there's got to be there's something like, you know, we're not triggering the SCR because the fuse hasn't exploded.
Right.
What's up, Kenny V? Thanks for joining us. You've got us on a particularly odd, frustrating night because we're getting our butt kicked by this TI-980 power supply for like the 4th week in a row. It's because we don't have the proper schematic is like the bulk of our problems. Now I feel like there's other stuff that we can check here. There has to be, like, so, you know, we're never seeing ref ramped come up.
Did we ever see all regulators up negative true?
What do you mean negative true?
It's a low voltage. It's a logic level low when it's true.
Oh, it was at 5 volts.
That means that all regulators are not coming up.
Wait, how do you know it's a...
The minus sign after the all reg. If you look at the backplane of the power supply, between the top 2 connectors, you'll see pin 54, all reg up, and a minus sign after it.
Yeah, low would be true on that.
Yep.
Okay, so that has to go low in order for things to be okay.
Yes.
And it did not go low. I mean, I can check it again with, we were checking it with the power supply out, but I mean, I can check it again. That's 53 and 54.
Shouldn't matter. That's coming from the linear board.
50.
Yeah, it's 53 and 54.
56. Oh, no, you're right. You're right.
Yeah. Yeah, that's at 4.9 volts. Just stays there.
Yeah. And
Okay,
check
so
56 right next to it says AC on, I believe. That should be low true also.
And that, I think, is the one that goes to the system backplane to tell the processor that it's okay.
Now that's
that one's
just
at,
going between the 2 boards.
you said that was what, not, that's 50, 55, 56?
Yeah.
That's at 10 volts.
I think 10 volts? Where's that? That's got to be, that's coming from the bottom board, I believe. Let's see.
Right, 55, 56. Where's that coming out of the bottom board at?
Come on. All these stupid parts list between schematics is driving me nuts. Let's see.
Yeah, I even read through all the part lists looking for any mentions of a relay or anything like that, just in case we might have the parts list but not the diagram, and I didn't find anything.
I spent some time this week working with the drawings that were made last week, and I came up with somewhat of a schematic of what we ended up with, which actually parts of the various parts that were drawn, and doing a little reverse engineering with the images, the pictures of the board, the board, came up with something I'm trying to snip right now out of KiCad.
AC on must be generated on the backplane because I don't see it on the other board.
All right, let me save that.
Although on the backplane, it looks like it definitely comes from the second board.
The bottom board, yeah.
Yeah. I wonder if this is a revision change that we're seeing.
Well, it's possible. I mean, it could be that it's never even used in this one, but in the B, it may not be used at all.
Yeah.
Or the A, who knows?
My lower regulator board is also very different from the one that's pictured. So we may be in a tough spot, but
yeah.
I'll see if I'll try to find where that 55, 56 is coming from, at least within this schematic.
AC
on is what?
AC on comes from the 5-volt regulator board. Pins 55, 56. There's a transistor that pulls it low. It's biased up to the plus 35 supply.
Oh. All right, so that explains the high voltage.
It's 10K.
But should be low true though.
Wait, where are you seeing that on the schematic?
Top left-hand corner of the 5-volt regulator card. First schematic.
First schematic. Oh yeah. AC on. Oh no, AC 0N. That slash through it is a 0. And that is an input.
I don't see it. What the hell?
Section B8, the upper left-hand corner of the first sheet 1.
That's definitely where I'm at. The memory, auxiliary, and reference regulator card.
5-volt.
No, on the 5-volt top board.
Oh, the top card, not the bottom card.
Yeah.
Yeah, so it's an input into this. Where's it coming from is what I'm trying to figure out.
No, that's the output.
All right, where's it going?
Yeah, it is.
Yeah, you're right. It's strange for them to put outputs on the left, but
Yeah.
so where's it going though?
Hung up on that.
Yeah, it's supposed to pull it low when the 5 volts comes up, I guess. So let's see.
Well, your 5 volt never comes up, so it's never going to get pulled low.
Over
It's driven from the
on,
flip of 4A, 4B, coming up to the base of that transistor.
on delay,
Yep.
negative true. But if we have,
box
we don't
supply
have-
to come up and power this, and then there's a 500 millisecond delay, and then this should come on.
but we're never
There's
getting the
waveform
5 volts
diagrams in
up.
Chapter 4.
Well, we're never getting the 5 volts up. So why would that even go true? Negative
5
true.
volt ref or 5 volt aux, which is a linear supply.
Yeah, unless
Yeah, it's
Q4 is
being
being
driven.
pulled low. So if Q4 gets pulled low, the Q1 will never kick off. So we need, I think there's a connection between Q4 and R10. You just can't see it.
Yes, there is.
Right.
Yeah.
So 5 volt
And then-
aux comes up, and 5 volt aux is going through this, and as long as Q4 stays off, that's going to turn Q1 on, which is going to pull AC. I know it's 0 in, but I'm going to call it AC on. It's going to pull AC on
Yeah.
low.
Yeah.
Now we're
Well,
seeing
if you look
AC
right
on
below
at
that,
10 volts, which is a weird voltage level. It's like Q1 is partially on.
Yeah. Yeah. With a 10K and a 10K to what is that? The next NPN.
Oh
they're
yeah,
all
so
222.
if Q1 is off, then you've got a 10K divider into the base of Q2, which will turn it on. So that's probably why we're seeing like 10 volts on that, because you've probably got a voltage drop across Q2 there.
Yeah.
So that means that Q4 is turned on, which means Q3 is turned off. It's all like one giant feedback loop.
Yeah.
So the C19 capacitor going into Q3 should be the time delay for P on delay.
C19.
Yeah.
Dog 6
But we
zone.
don't know. That's on the B. We don't know what's going on with the A.
True.
This could be very different.
Also, like I feel like we're barking up the wrong tree here.
Yeah.
Like I feel like we tried to figure out where the AC on signal goes, and then we got caught up in this whole mess right here, right? But I don't, like, AC on, near as I can tell, doesn't go anywhere. Like, I can't find it on the bottom card, and it's not on the backplane. So why do we even care about AC on? We don't
It
really.
was just going between boards. I was thinking maybe it was originating from the analog regulator board, the bottom board.
I couldn't find
But we
anything on the
haven't-
bottom board that talked about that,
Yeah.
that mentioned that at
Yeah.
all. But we do know for a fact that all regulators up is supposed to be active
Is not-
low,
Yeah.
and that is currently high. And all regulators up does play into the whole overload on delay circuit, right? Like it's a solid input to that.
Yeah.
So I think that's where we need to run down next. So
still
all reg up is
say-
on the other card. It's coming from the bottom card.
Yeah.
I gotta figure out which page it's on. It's in a weird spot if I remember. Yeah, there it is. Okay. So all reg up is going through Q36, which is in A5T 222222. Then Q28 plays into that as well. CR20, CR21, that's all part of it. Ultimately, what should the signals in be to make all reg up turn on, or go low rather? To essentially turn Q36 on. What do we got to do to turn Q36 on? We've got to turn Q27 on and Q26 on. What a weird setup this thing is. My brain is not parsing it. Oh, so you've got Q28, which is, that's your output signal from the -5 rail. So do we have -5 volts? If we don't have a -5 volts, that says that all of our regulators are not coming up, right?
No.
These could all be easily measurable because they're all analog.
Yeah, so that's what we need to check yet. We know that +5 aux and +21 aux are good. We know that +5 ref is good, but I don't think we've checked -5 and +12 mim. So let's check those. That's going to be 71, 72, 75, 76. How many pins are there in total? Is it 80 or is it 76? No, it's 80. 80. So we've got 80 pins. So 79 and 80 are ground. So that's 80, 79, 78, 77, 75, 76. That doesn't seem right. I've got 75, 76 tied to ground on here. But that says that should be +12 mim. Actually, that's not even ground. That's +35. I think. Yeah, this board is very, very, very much so different. Oh, I'm looking at the wrong board, first of all. That would be why it's very, very different.
The regulator or the aux board?
Yeah, I'm looking at the regulator board. I'm like, no wonder nothing's lining up.
Yeah, because at the end of the last 20 pins, the last 15 pins on the two cards are very different.
Yeah. Yeah. All right. So, without the top board in, we should still get all the regulators coming up correctly, right?
Yep. The only thing I'm seeing, I gotta go back to the schematic, because it looks like +5 cents may get into that all reg up, which might be our problem, which might mean we never get it.
Well, we can give it a shot at least. So we've got 79 and 80 on ground here. Then 79 and 80, 78, 77. And then 75, 76 is this guy, which should be our +12. And I'm pretty sure that you are ground. The logic common is the same between the boards, I believe. So you should be +12. You're showing 5.4 volts. That's a little weird. That's 75, 76. The next one is 72, 71. So 75, 76, 76, 75, 74, 73, 72, 71 is at 0.0. So at this point, I'm not sure that our pinouts are the same.
That sucks.
Yeah. I have a negative 8.6 volts on here. Well, hang
Negative
on.
8.
Let me just. What's it? 18. Where are you? Again, 5.1 volts. What's the voltage difference between here? 0. Right. So I'm pretty sure those are connected. Yeah. Okay. So I was measuring ground from the correct place, but I mean, our plus 12 was showing like plus 5, and our minus 5 was showing 0. But I found a minus 8 somewhere, and we shouldn't have a minus 8 showing up at any point, right?
Where did there's my schematic.
All right, so
Kinda
79
remembering
and
something like that.
79. Let me write this down. I'll just go through a collection of I really need a pencil sharpener in here. I'll go through a collection of pins on there, write down what the voltages are, and see if we can cross-reference that in a way that makes sense to the schematics that we're seeing.
Okay.
So 79 and 80 are ground. GND, and then I'll do 78, 77, 76, 75, 74, 73, 72, 71, 70, 69.
Those are all going to be 5-volt rails.
No, they're not.
Doesn't change until you get to 3132, which is plus 15.
I think you're looking at something different than I'm looking at.
Oh, opposite direction. I was going from 80 down. Sorry.
I'm going from 80 down, but 80's on the far right.
Oh. Yes.
It's on the far right if you're looking at the back side of the board.
Yeah.
Yeah. So 70 to 69, 68 to 67 is our battery thing. And then
68, 67.
Battery?
Battery?
Yeah, that's battery plus.
Oh. You're talking on the top board, not the main the connection to the motherboard or to the CPU backplane. Okay, yeah, you're right.
According to the schematic, but like the numbers that I see. So I'll go all the way down to 68 and 67 and see what voltage levels I see on these. Move you over to here so I can do it with my right hand. Let's see here. So you are going to be 20.6. That's a lot. You are 5.4. These voltages make no sense to me. You in particular make no sense at 1.4 volts.
What pin?
Hang on, I'll read them off here to you here in a second.
Okay.
Which connector are you measuring on?
Hang on, let me.
5-volt regulator board.
Okay.
What was that? -8. There it is. -9.
What are you using for your ground reference? Pin.
Well, that's -21. That's fun. Hang on. Let me. Once I get through this, I'll bring everybody up to speed. It's 21.1. -32. That's a new one. Here's 0.8. .7. These are all numbers that don't make any sense in the world of computer logic. 0.2. And the last one here is 5.05. All right. Let's see here. This is 66 and 65, 64 and 63, 62, 61, 60, 59, 58, 57, 56, 55, 54, 53, and then 52, 51 is ground, 49, 50 is ground, 79 and 80 are ground. Those are all tied together. Double check that. Okay.
Oh, yeah.
Yeah, so, okay, so pins 79 and 80, 51 and 52, 49 and 50 are all ground. They're all tied together on the board. I confirmed that. So I was using that as my ground. Now, here's where things get weird. 78 and 77, I don't know what those are supposed to be. That's our plus. 78, 77 says it's our plus 35. Right?
I'm looking at the backplane here, and it says 7980 is plus 35.
That's not what the
That's
schematic
weird.
says. I think you're
I'm on the
you've got some-
backplane drawing.
I'm on the actual like schematic for the board drawing.
Okay.
XA2 connector or XA3 connector?
The main backplane connection.
Okay, Usagi was measuring on the memory aux connector, I believe.
No, 5-volt regulator.
Now I'm on the lower board, whatever the lower board is, the one that has a
Oh, the
boatload
lower
of
board.
big transistors on it. Yeah,
Ah,
that's the board that has the all regulator up on it. That's the board I've been on for like the last 20 minutes.
yeah.
Right? So, according to that schematic, 78 and 77 should be plus 35. I've got 20.6 on that. That's not a great start. 76, 75 should be our plus 12 mem. That's at 5.4 volts. Also not great. 74, 73, I have no idea what that's supposed to be.
5 volt. It's 5 volts, but STB makes sense.
But that's the problem is, at least on the schematic I'm looking at, that should be the aux regulator, not the 5-volt regulator.
That's coming from the battery though, so it shouldn't really matter.
And like
All right. Well,
all the
at
pins
any
you're
rate,
mentioning are on the connector for the XA3 connector for the MEMOX and reference regulator board, which is not the main 5-volt regulator card.
yes,
Right.
that's the card we're checking.
Okay, I just want yeah. So XA3.
That's the card we've been on for like the last 20
I know that's
minutes.
my thought, but
Yes, that's the card we're on. That's the card that generates the all regulators up signal.
correct.
Yes.
Okay, so
Okay.
yes. So it should be ground plus 35 plus 16 or 12.
Plus 12 mem, and then plus
Oh,
5
yeah.
standby, that's actually at 1.4.
And then minus 5.
Yeah, and the minus 5 is at 0. Like 0.0 something.
And then the
That's
next
not
two are
a
not
good sign.
used.
Where's the, make sure that I'm familiarizing myself with where everything is. Yeah, there it is, 722. So this is minus 5V. 69 and 70 has 6.99 volts on it. So there's
Hard to say.
something there.
That just goes on the backplane. It only goes to a test point, or an E anyway, E7, which is closely related to E5, E6, and E8, whatever they are.
On the schematic,
They're jumper points.
Yeah,
on the schematic, it shows that as plus and minus 35 VAC.
There's two E5, 6, 7s, and 8s. There's one between the two connectors that's a single circle, and there's one down at the bottom, which is on the external backplane.
E5, E6, E7. Yeah.
All right, 68, 67. '68, 67 is our BAT plus. That was sitting at 6.2 volts. That's interesting.
That's going to be whatever the charger voltage is coming off this card.
Oh yeah, because it's going to try
Yeah.
and be charging the battery up. Got it.
Yep.
All right, then 66 and 65.
Are the SCR drive. No, I'm sorry, they're not. They're 19 volts or something like that.
That's what I'm seeing. No, plus 9.
Plus
Plus
9. Yep.
9 volts or something. Yeah.
It's coming from
Oh.
a bridge rectifier from the transformer.
Unregulated plus 9.
Well,
Yeah.
the good news is that one is correct. Or not. I measured it as negative 9 volts. Yeah, I measured that as, so on the board that came out to minus 9.
Looking at the diodes, I'd say that's correct. I think. Because coming from the CR5, CR6 bridge.
Well, the currents are the
Cross C1
yeah, the
and
cathode would indicate a positive voltage.
yeah, so that should be plus 9. Minus 9 should be on the other one.
Yeah, minus 9 is on the other pair.
Which is 61, 62.
That was negative 32. Oh, it's midnight. Printers are reconnecting.
Yeah.
All right, let's keep going down the list here. 64 and 63. What
That's
is that?
SCR drive.
Where is that coming from? Is that
That's coming from the I think the board you're on, the 5 volt. Or not the 5 volt, the MEM.
yeah, the aux board?
Yeah.
I don't see it. We're still looking for it though.
It may be coming from the 5 volt, but oh, wait a minute. It would have to, because that's the only thing that would drive the SCR.
Yeah.
All right, well,
it's coming
well,
from 5 volt.
that one I measured
That's
at
the crowbar for the 5 volts. Main 5
Yeah.
volt.
Right. Why it's stopping at the MEM aux board is unknown.
Spare pins they're just routing through to get the trace to the other side.
It's not as though they need a lot of current.
well, I measured that one at
No,
negative 21 volts, but that could just be because we don't have the other board in.
Yeah.
61 and 62.
That should be a -9.
That's -9. Yeah.
Where do you see that one coming from?
Comes off of the bridge rectifier in the chassis.
Oh, that's from the
Yep.
backplane.
Yep.
Right.
Comes off CR1, I'm sorry, CR5, CR6.
Well, I measured that one at negative 32.
That's suspicious.
Yeah.
So far, almost every pin on here has been suspicious.
I'd be looking. Let's look at the backplane and see what our actual voltages are like around the transformer and the bridge rectifiers.
Well, hang on. Let's finish out this list that I've got here because I measured all the way down to logic common. So 59 and 60.
That's reset.
Memory reset. Yeah. Negative true.
That's mem reset. So that's coming from this board or not? I don't see it on here.
Could be from the memory controller. Let's see.
Yeah, I don't think it's coming from this board.
Yeah, I've got to go back and look at the system stuff. But at least on the B, I think that battery is to keep solid state memory alive.
Yes,
yeah,
it is.
Yeah, that's what PDP deck did the same stuff.
Memory controller, DMA.
Yeah, I don't know what 6259 is. It's not coming from this board. You said it was memory reset?
M reset minus.
So low true.
It was at 0.8 volts. So whatever that means. All right, 58, 57.
That should be plus 35.
It was not. It was 9.7.
And that's coming right off the 35 volt bridge.
According to the block diagram.
Actually,
Go
no,
ahead.
plus 33. It's a diode drop below plus 35. So this is plus 33, not 35. They have a diode isolated 33 volt.
Yeah, but I have the thing is that I've got plus 35 on the other board. And also I've got plus 35 on 78 and 77.
Right, but this goes.
All right, I'm gonna have to go up to the backplane schematic, I guess.
Yeah,
What's up,
there's a
Jacob?
one end.
I mean, we may very well be seeing a lot of revision changes happening here.
Sheet 2.
Yeah, you've got that as plus 33. Yeah, you're right. On the backplane, no idea what
Yep.
the heck is going on
It's
here.
a separate bridge from the plus 35 bridge, so one could fail and the other not.
And then 56 and 55,
That's AC on.
and that was at 0.
So it says AC is on.
Well, it
Well,
doesn't
it's
say it doesn't say anything because the AC on is generated by the board that's
Yeah.
currently not plugged in.
And then reg up is your next two.
Yeah, all reg up, and that was at 5 volts.
And then we got two ground pairs.
Yeah, that was okay. So that was as far as I measured.
Okay.
So I'll take a
M
picture of this
reset.
and post it in.
M reset is coming from the 5-volt regulator board.
So that would explain why it was also at nothing.
It's an NPN transistor. I don't see it. Oh, there's a pull up right there. So 100 ohm pull up to 5-volt main. So that explains why it's low.
Well, the car's not even in, so yeah.
Yeah.
So the
So-
plus 33 looks very suspicious.
Well, so the plus 33 looks suspicious and the minus 9 looks suspicious, right? How's our
Yes.
minus 9 being generated? Where's that at?
Another bridge on the main back.
Yeah.
CR5 6 coming off another set of taps on the transformer.
Yeah, so CR5 and 6 there, which go across
That's
C1 and
plus
C2. That's our plus 9 and minus 9. Minus 9
Yeah.
is CR8, CR7 and 8.
Yeah.
Yep. And then CR3.
CR4 is half wave rectified, or plus 33 is just half wave rectified through CR4.
No, it's CR3 and CR4 makes it full wave rectified.
Oh, does it tap into something else up there?
CR4.
Oh yeah, it does.
Yep.
God, this
Yep.
is drawn terribly.
Yeah.
I hate this.
It's your standard center tap full wave.
Yep. Yeah, I got it. I got you.
CR1 and 2 are plus 35. CR3 and 4 are plus 33.
So I feel like something is definitely bad on the backplane here.
It's
Right.
working that way.
Let's pop this card out.
So those should work with both cards unplugged.
Yeah.
Yeah.
But I got to figure out what
I'm
to
sort of suspicious of F1 and F2.
probe. So I've got CR5, 6, and then 7 and 8. Those are the big rectifiers right underneath the slot. So 5, 6, 7, 8. It's going to be, these 4 right here.
So your
and
9
that's-
volts is where your 5 volts is regulated from.
Yeah. So our plus, so I should have plus and minus 9 volt coming straight out of CR8 and CR5. if I can
With
figure
your
out where to,
common on the white wire, you just put the lug on.
yeah, so I should be able to check that. Hopefully without lighting myself on fire. Let me go get a, let me get a alligator clip here.
Yeah, I was gonna say, now's a good time for some clips.
Yeah.
No slips allowed.
Yeah.
Yeah, well, I mean, they're allowed. It's just how exciting do we want the night to be, you know?
I like your outlook.
Unlike Microsoft's.
I think it's fantastic that we were able to send people around the moon, but not give them a functional mail program. I find that absolutely hilarious. All right. So,
Corporations got to corporate.
yep. So which CRs do I need to be checking? I need to be checking CR8 and CR5. Which are going to be right at the top there. And I need to check the
CR8.
butt of 8 and the head of 5. So I need to be on that side. Got it.
Yeah.
First of all, are you going to explode on me? No. All right. So this is CR5. That's at 11.9 volts.
Okay, I'll get that
Unloaded. That
unloaded.
makes sense.
And there's CR8. That's at negative 11.9 volts.
Okay, that looks good.
Okay.
How about CR3 and CR4?
Oh, Jesus. I don't know where those are.
They're one end 645s, whatever those. There should only be 4 other diodes on that backplane, so it should be. I'm betting they're just. I don't know how high current they are.
Well, I can only see 2 other diodes.
There should be 2 1134As and 2 645s.
I mean, I hear the words that you're saying, and I regret to inform you that they
Wait a minute.
do not.
I might be able to point them out to you. Where
I mean,
is
I can send you a picture here. This is a very different situation that's going on here.
That's true too. Oops. Why is it going diagonal? Oh.
So I'm pretty sure. Oh, I've got 2 big chonker diodes. Okay. So I've got 8 diodes in total. Does that make sense?
That sounds right, plus 1 SCR.
Yes. That is correct. So the chonker diodes are CR1 and CR2.
Those are your plus or minus 30. Those are your plus 35.
That's
Yeah.
the one that created a light show the first time we powered this up.
Yeah. Yes.
So I should be able to check. Those 2 are going to have, those 2 are tied together on one side.
Yes, that's the output.
That's the output. So I should be able to check that and see a plus 35 on that, right?
Yep.
Yeah. And I got a plus 40 because it's unloaded.
Yeah.
Okay. The other 2 diodes are much more difficult to get to. I think they should be what?
Well,
CR3
they go
and
right to
CR4.
your connector where you measured them.
Well, okay, they should be CR3 and CR5, right?
CR3 and 4. 5 was the one you just measured.
I'm looking at R5.
R5
Right next to the. Are they right next to the Molex type connector?
Yeah, CR3 and CR4. Yeah, they're the 2 right next to the Molex connector.
Yeah.
So I can get to the head of both of those. Does that help? CR4. Do I need to get to the butt? No, the head of those should be
Maybe
plus
head.
33. Or the head of, oh, those are tied together.
Yes.
Yes.
Okay, so if I can check the plus of one, that's the plus of the other as well.
Correct.
Yes.
Okay, I got that. I can do that. Well, I said I could do that. 27.
27.
That feels low.
Yeah. That sounds, yeah. Can you get on them with a meter and see if they look rectifier-ish?
I mean, I'm on, what do you mean with a meter? Like with a scope?
I was
No,
just
with-
looking at the diode range on a meter and see if they actually measure like diodes. Like one
Oh,
might
yeah.
be open.
I did that when they were out. And they both measured like diodes. I can try again though. But you're right. If one of those is open, that would.
Well, it might be hard to measure it because their heads and tails are both connected together through the transformer.
Yeah.
So you
So,
might need
yeah.
to look at it. You might need to look at it with the scope.
Yeah.
In
I
case you're
think,
getting full wave or half wave.
but without a load on it, would we even be able to see that?
Well, with the big honking capacitor on it, it would be flattened out pretty much too. But you
Do
would
they-
get a definite 30
Wait.
volt, I mean 30 hertz or 60 hertz bump in it anyway.
No capacitor on those.
Yeah, CR3 and 4 don't have a capacitor.
They don't? Oh,
Nope.
So
They just go straight to the
Oh, the
aux
30.
card.
yeah, the 33, the 33 plus and minus 33, that's the big.
all right. Of all the ones to try and check with the scope, that's the best one.
Because that was the one you were measuring like 9 volts or something weird on.
What is that supposed to be? Plus 33 and plus
It was,
33?
it was pin.
Yeah, I was getting-
57.
Yeah, I was getting 9.7 volts on that.
That's suspicious.
Hey,
Yeah.
guys,
That's just
I see
like
a
that.
cracked solder joint.
Could
What?
be a cracked solder joint. Could be a bad
Have a look
diode.
at the image I just sent in Friday night.
Or it could be something loading the hell out of it on the aux board.
Well, the fact that we're seeing just 27 when there's like
that-
zero load
that's why
on
I'm
it.
wondering if it's half wave instead of full wave.
Yeah, that's what we're going to check right now. I just had to go get a power cord.
Have a look in the Friday night chat one.
Yeah, give me a second.
Yes,
I'm in the middle of
okay.
something.
That looks
Uh,
interesting for sure.
There's probably about 40 cracked solder joints on this thing. So it would not surprise me if you found one. All right. What do you got for me? Where is that? What am I looking at there?
That's on one of the diodes mounted to the panel right beside the Molex connector with the orange wires. It's got the purple and white wire going to it.
That's CR1, I think.
Yeah, with CR1, those checked out fine, and it's not cracked. It's just gross, man. Like I could see it in
Yeah,
person.
yeah.
It's fine.
That's just a fug.
It's just covered in corrosion. All right. I wonder if I can get a clip onto that diode. That would sure make life a whole lot easier here. Then I don't have to try and stab this thing from a distance. Yeah, we'll give that a shot.
I'm kind of wondering if this power supply, backplane, motherboard, whatever, isn't the same for everybody. The only difference is in the 5-volt regulator and MEMOX
Well,
boards.
given there was a 980, a 980B, and a 980A, I would not be surprised if it carried forward. That looks
Yeah.
pretty full wave.
That looks pretty. Yeah, that's full wave. Yeah.
Maybe it's just because there's no cap on it. We're not getting any averaging, so the
Right.
Yeah, so the multimeter doesn't average it. That's why it measures low.
Yep.
But that's 40 volts peaks.
Yep. 40-volt peak. I call that good.
Yeah.
If it were full wave, the frequency should be 120 volt or 120 hertz, right?
Yep.
Are you not going to measure this for me? Come on, scope. There you go. Yeah, that's 120 hertz.
Yay.
There you go.
Okay, so
everything looks good up to the card.
Except for the 9 volts, -9.
Bob, that's from 0 to plus 40. So peak to peak as well as peak?
It's ground, it's peak because it's no negative. It's all positive.
Yeah, it's all positive. Because it's full wave rectified.
Yep.
Right.
Yeah. So
But I thought we measured like plus or minus 12 or something on the 9 volt. Do you just
Well,
measure?
so the issue now is that the pinout of the schematic may very well not match this pinout here. The pinout of my
you should
actual
be able
card.
to own that out. You should be able to own that out. I'm wondering if you measured that with the card in, right?
Well,
Yeah.
if we got the same backplane for the 980, 980A, 980B, then it would be the same no matter what. Which I'm kind of leaning towards right now because that wouldn't really necessarily need to be redesigned for any particular reason. I think the reason they redesigned it is because they were going from core with the 980 to solid state memory in the 980A. And they only changed the 5-volt and MEMOX boards, which makes sense because it's looking like from the pictures I've seen, the layout of the backplane board appears to be the same.
Well, I've got a serial number on here. And I've got an assembly number. And I've got a schematic number.
Yeah, assembly number might help.
Actually, if you got the schematic number, we've got the schematic, so that should match.
It's 226833 for the schematic number. But I can't find a schematic number that I can read on this actual schematic. It looks like a 684 or something like that on the drawing number in the bottom right.
22683. Oh, dang it. Come on, where is it?
Actually, does it show up? Is the assembly numbers that show up in the parts lists?
4368. Drawing number is 43684.
Yeah, my assembly number is 226831. The schematic number is 226833.
That doesn't make a lot of sense. Let's see. Transformer wire. Power supply assembly. Kit.
All right, well, my next curiosity is if we measure that same pin on the card with the card plugged in, what do we get? Right, that was 5758, which is our plus 33 volts.
Yeah.
So if we see the exact same signal, that tells us that that pinout, at least for that part, matches.
With 9.7, I'm wondering if you don't have a bad capacitor on there.
Yeah, that's what I'm trying to check. So if, you know, with the scope, we should be able to see if we've got like insane pull down or something, right? So here's 53, 54, 55, 56, and then 57, 58 here. So no, that looks the same. I've got 120 hertz, peaks at 40 volts.
And it doesn't even look like it's smoothed at all.
No, it doesn't. So where does that go to on this card?
Okay, I'm going to say it's a different assembly because it looks like on the 980B it would be a 943687 schematic and a 9 for that rectifier filter backplane.
Let's see. I had no. This one.
So is that plus 33 even used by this board?
Possible it's not.
If it's not, then that would explain why it looks exactly the same.
If you unplug it and physically look at it and see if there's any connection to it.
I mean, there isn't on the backside. What is it? 56 and 57? Oh yeah, no, there's if it's not a connection on the backside, it's not a connection on the front side. That's for dang sure. There are no connections on the front side. So yeah, that's unused. It's unused by this board. So that's not even one worth worrying about. And actually, there's a couple more not even worth worrying about on this board. So let's see here. That is 53, 54. So 53, 54 is used. 55, 56 is used. 57, 58 is not on aux. 60, 59 and 60 is also not on the aux. 61 and 62 is used. 63 and 64 is not used on this board,
right,
which is the SCR drive. So 61 and 62 is another one that was a little weird because I measured that at negative 9 volts. Or I measured that at negative 32 volts. But that should be negative 9 coming from the back.
Did you measure it with the 5-volt regulator card installed?
No.
So it comes from the 5-volt regulator card. So
61 and 62 does? That doesn't. No. That comes from the backplane.
Yeah.
6162 is our -9 from the backplane, I thought.
Okay, I'm on the wrong pin.
+61 and 62. There's our +9. Where's our -9? It is used by this card. I can see a trace on there. I mean, I think we have probably a pretty gnarly couple, maybe a couple pretty gnarly failures on this board.
Yeah.
But I sure shit can't find where the -9 is coming in on this guy. 61 and 62. I mean, I can see a legitimate trace on here. I think. Oh no, 61, 62 was used. Let me double check this. So 53, 54 is used. 55, 56 is used. 57, 58 is not used. 59 and 60 is not used. 61 and 62 is used. That is a big fat trace that goes off into elsewhere. 63 and 64 is not used. And then the rest are used. Yeah, so the -9 from the backplane, which I measure at -32. Let's see what that looks like on the scope. Let's see what all these look like on the scope. See if we're just seeing like wicked ripple on anything. And I'm guessing that the center tap, with the card plugged in, the center tap, which is what I've got my ground currently on, is the same as the logic common and all the other grounds, right?
With it plugged into the motherboard, yes, but generally just the
Yeah, I'm currently plugged into the motherboard, so we're good on that.
Yeah, so it shouldn't matter. Yeah.
So, I mean, I think it probably does matter because I am, even on the scope here, all reg up, which is 53, 54, is coming out at 25 volts. Am I? Yeah, you're
All
on
reg.
10x. Yeah, so there's yeah, all reg up is coming up at like 25 volts. AC on is coming up at like 15 volts. Wait, how's my 0? Oh, well, no, hang on a sec. Let me do that again. Yeah, 25 volts. That's at like 22 volts. So I'll tell you what, let me disconnect from the center tap on the backplane and see if I can get onto logic common here. Because like maybe we just have an issue with logic common not connecting to something else, you know?
Yeah. Yeah.
All right, so if I check all reg up.
Well, we did check that voltage on that board anyway, and there was 0 volts difference between ground and LC.
But something's not right here, because now if I put the ground pin of my probe on logic common and check all reg up, it's at 5 volts. But if I put the ground of my probe on the white center tap of the backplane, I'm at 25 volts. So I've got a 20 volt difference going on between there.
Okay. That would be power supply main board.
So our ground the ground on
tap.
this board, which is a bunch of, let me go back up to the backplane here. Because if we have disparate grounds, that would explain why things are not firing up, right? So the logic common on the backplane should have, does not have. So how do you get back to that white center tap?
If you look at the power supply backplane schematic,
Yeah.
you go through the white wire P3 to J3, which I guess is the Molex connector, which could be an issue,
Yeah.
and
Well, I
straight
don't
up
think it is.
to pin 65, 69, 73
Yeah, but that's on the top board.
on the top board, right?
Oh, so if the top board's not installed, the logic common of the bottom board is floating.
Never makes it to the bottom board.
So that top board has to be in place in order for the logic common to actually make a connection to the real ground.
Looks
So-
that way.
So the bottom board will never fire up unless the top board is in situ.
Pain in the butt.
This is a terrible design.
And I'm also, unless I'm missing it, the plus or minus 9, I'm not seeing it in these schematics.
The plus
Unless
9
I
was
missed it.
was on the aux, but the minus 9 I never
Right, but
saw.
I'm not seeing it used there.
No, the plus 9 is used on the aux schematic.
Yeah, the +5 regulators is getting its power for the entire 5-volt rail from that plus 35 volts or plus 9, I believe. Now wait a minute, you may be right.
Yeah, so the plus 9 comes in, goes through CR4, gets smoothed by 22 microfarad, goes through Q11, and that produces the plus 5 standby.
Ah, there it is. Okay, yeah. And the 35 volts is used for the switching regulators on the +5 volt regulator board.
Yeah, I never found any place that used the -9. I didn't
Yeah,
see
well,
it anywhere.
that- Yeah, I don't see it. Oh, wait a minute.
But
Yeah, it's all of our.
I think we're pretty confident that the thing is never going to, like, this bottom board effectively is off.
Yep.
Yeah,
Until
and
we
if I
plug the
remember
top
right,
board
I have
in.
to go look. Their troubleshooting procedure has you jump some things if you're running with only like one board in.
Yeah, you gotta bring the ground around, which is what this thing does. That's
Yeah.
infuriating, man. These guys are nutso. Now if I plug that in, I can't measure anything on the bottom board.
Okay.
Well, they do say to
You have-
work on this, you're supposed to use the power supply extender board that you don't have.
Yeah,
Yeah.
yeah. I'm getting awfully
could-
close to Meanwell City.
You could conceivably put a jumper between that white wire, it's the center tap, and the big honkin' 67,000 microfarad capacitor negative terminal, and that would tie everything together.
Yeah, I just got to go. Yeah, I just got to get from that the white wire terminal to the logic common on the lower board, and that'll at least fire the lower board up.
Yeah.
Like, is it even worth saving it at this point, man? Like, this thing is such a hunk of junk.
I could, but you wouldn't have a case to work with to put your mean wells in if I did.
And I'm confident that we could fix it eventually.
Yeah.
It would require sitting down and reverse engineering everything. And probably we would end up chasing faults and parts, like failing parts, for its entire life, because everything is so corroded and nasty in it.
True.
I mean, like the fault that we're seeing right now could simply be a trace has corroded through and we just haven't seen it. Right?
Yep.
Particularly on this bottom board. Like, things are real nasty on the bottom board here. I mean, I could have any one of these. Any one of these.
Yeah, the bottom board.
Yeah, so like any one of these could be bad, which, by the way, this layout doesn't match the schematics that we have at all. So we would have to like fully reverse engineer this board to figure out what is working and what isn't. You know, like, these screws are fully rusted through right here.
Yeah.
And I'm pretty sure the case of a 2N 3756 is a connection, right? And I can see that it's just like rusty grossness under here. So it's entirely possible that both of these transistors here are out of the system completely. This transistor has all sorts of rust on it. It could be dead. I mean, I think,
Yeah.
like, I think what, you know, if we want to do a last ditch effort, we pull all these transistors out, pull this off, clean all the connections on the bottom here, and then put it back together. I'm pretty sure those are all in sockets, so we could
I was
try
gonna say, if
that.
they're socketed, that wouldn't be too bad.
Yeah. I mean, we could try that, and I could do diode checks on them while they're out. That one we know is good because we replaced that one. We already had one fail on here, right?
Yeah. Well, big gaping hole in it anyway.
No. This is the one that we replaced last week. That the diode check was fine, but when it was in place, it wasn't starting up.
Oh yeah.
But it's the little guys that I'm like worried about, you know? The 2N 3766s, because the screws for those are just like made of rust at this point. I'll take a picture here and post it up so that way I know where everything is. But you know, beyond these guys being bad though, and there being bad connections on these, like, I'm kind of out of like ideas at this point. We need to reverse engineer the full board.
Yeah, the whole thing. Yeah.
Because this board is very dramatically different than the other board. The other board is
Closer,
also
but not.
it's closer, but also dramatically different in some places. I think the backplane is probably the only thing that's shared.
Yeah.
I'll even pull out my old 2N 3055 or my new 2N 3055 here. I mean, I probably should have done this early on just to get a look at how bad the rust is underneath there, because it is not great.
Definitely time for a few new screws. I can see the rust from here.
Yeah, and if those 2N3766s go through, like
They
their
do.
case, their case has to go through those screws, right?
The case is
Sure
the
does.
collector.
So if we've like lost connection because they have decided to completely rust out,
Jeez, that's horrible.
yeah. And I don't even know. Yeah. I don't even know what these 2N3766s are for, because
The drivers.
yeah, but I mean they're not the same as they are on, boy, that one doesn't want to come out. They're not the same as they are on the schematic.
Nope.
Oh, you are crunchy. There you go. This one is particularly bad. I may not be able to get that one out.
Oh no.
Yeah, I think the socket for this one is hot garbage. Okay. Oh man. All right, let me get my new 3055 out.
Yeah, on the B schematic, the heat sink is probably just it's a TO3 can with one of those webby kind of slip over the case type of heat sinks.
Yeah, whatever this one was, I'm not sure that one was even making connection on the normal pins.
Oh,
That socket was not great. I mean, it just kind of fell out. I need to get a pick. Hey, Sue. I mean, the question that we're trying to answer here is like, yeah, if we spent enough man hours on it, we could absolutely revive the thing, right? But like, at what point is it worth cutting our losses and just going, let's just put something better in, right?
yeah.
Because otherwise, we're going to be doing TI-980 power supply streams for the next like 3 months.
Not only that, the worst risk is that we could get it working long enough to start doing things with the machine in earnest, and then have the thing fail in such a way that blasts the machine.
Yeah, that's what I'd be worried about.
Everything's got mica under it, right?
Yeah. Oh my God. I can hear the rust.
How are the computer boards comparatively to these boards?
Not much better.
So we don't even know if we can save those. And even, the best case, we get a perfect working power supply, and then the computer itself might never work.
Yeah, that's like a legitimate, distinct possibility. Oh my god, I'm gonna have to.
Screwed in from the bottom.
Yeah. That screwdriver's too fat, though. I mean, I said tonight was a night of discovery to discover whether we, give this one the finger and elevate ourselves where we mean well about something.
Yeah.
Or whether it was going to play ball, but right now it's certainly looking like it's not going to play ball.
Yep, I think
When
you're
you
probably
get
right
to-
on that.
When you get a little time, if you could take some pictures of the
That's so
processor
gross.
board, of the processor boards, memory controller, and the memory boards. Oh my God.
I've got pictures of those somewhere. I'll post them up tomorrow. I've got pictures
Okay.
of those saved.
I mean, I think the real problem is going to be, do we have any schematics for a 980A for any of the boards?
I even went directly to TI the other day. And they have nothing. Nothing in their archives.
Right. So I'm willing to bet that these sockets were not making good connection.
Those two look like they're just phenolic type sockets that were just sort of kind of kludged in rather than plugging directly into the board.
Well, it's also interesting they don't have.
Because like the 3055s have special pin connectors that are actually soldered into the board, whereas the 3766s have those stinking phenolic. I hate those phenolic type connectors. They're a pain in the butt.
Yeah, this is gross. So those two that are
Can you take
phenolic are listed as. Can I take a picture of what?
List of that area of the board.
I did. I posted it up.
Oh, you did. Oh. Okay, I've got the one with the transistor still in place. Okay. Oh, they didn't even do that. Okay, they got sockets there too. That's weird.
Yeah, this is crunchy.
They went a different route later on. They had individual pins that soldered directly into the circuit board, and the transistor base and emitters plugged directly into that. And then they had I don't remember what they called the threaded portion, the collector connection. Well, not really a standoff, but a something that you press in to make connection, and it's got screw threads in it. And they use that directly with the I mean, they make the connector out of the circuit board rather than having separate connectors. This is crazy.
All right, so because I don't want to have a bunch of disparate parts hanging out on my desk here, I'm just going to flood the thing with deoxit, and we're going to put it back together, and then we're going to plug it in, and if it miraculously works, we'll continue troubleshooting. If it doesn't miraculously work, then
Meanwhile,
Yeah, I think I'm ready for a meanwhile. I'm tired of mucking with this thing.
I'm tending to agree at this point.
I mean, it's one of those things that
This
like
is a lot.
I'm sure we could repair. It would just take
Yeah.
a year.
Yeah. As
Yeah,
bad as this is
I'm
now, I didn't realize how bad it really was.
yeah, looking at those transistor sockets, man, I would just say get your meanwhile order out.
Yeah.
And I don't think everybody coming up together is going to be a real issue. Supplies coming up at different points for solid state system isn't really an issue.
All right, let's get this guy back on. That's gross. Oh my god.
And I almost scrubbed those socket assemblies with simple green and then hit it with deoxit.
This thing needs an exorcist is what it really needs.
Well,
Oh, it just needs the last rites.
Or C, all of the above.
sprinkle holy water on it.
Yeah.
Maybe salty holy water while it's plugged in just to make sure it dies.
Make sure it's dead.
All right, let's get one in on this side here. Let's get those two little guys back in. And then I'll worry about... I don't know what you are. That's kind of strange. Also, you're going to be a terrible connection to whatever.
I mean, you have some not so rusty screws to at least try to get conductivity through them.
Yeah, I'm going to put some new screws in there. I'm not putting new thermal paste on, though. I don't feel like wasting that much thermal paste.
No, not for processors paste.
No, this would get the old cheap white paste
Yeah.
or just mica insulators.
Well, it's got mica insulators already, but
Yeah, and those are just like coarse threaded screws. Where'd my box of screws go? I must have put it back outside. No?
Well, I'm going to have to bail because I got to get up in 5 hours for work.
All right. Thanks for joining.
Thanks.
I'm going to... Oh, there it is. I'm going to give it the beans one more time, and then we're done for the night.
it's 1 o'clock.
Yeah.
We're already an hour past printer reset.
Yeah. Yeah, that came and went. All right, well, I'm going to get another one of these guys in. Maybe that'll help keep things straight. So if we do go the full Meanwhile route, we need, like, what does the computer actually need? There's so many voltages being generated, but I don't actually know what makes its way to the machine. +5, we know that much.
+5, -5 for RAM, and +12, I believe, are the main ones that are needed. CPU only needs +5.
I imagine that the I/O board also needs the negative voltage. Well, it's a 20 milliamp current loop board actually, so I have no idea what voltages the
Yeah.
I/O board needs.
I haven't looked that far. Just the main board is all I've looked at on the backplane. Let's see.
You're just not gonna thread in, are you?
I wouldn't be surprised if the processor boards were basically exactly the same as the ones out of the original and the B. Just the memory controller and memory, of course, because that was core.
Yeah.
And the B memory is later versions of MOS technology. So probably the +12, but probably not even needing the -5.
So it sounds like it's all pretty standard stuff.
Yeah,
I mean, that should be relatively
That's
easy to
what-
redo.
yeah. Oh, and the control panel +5, that's it.
I mean, if we don't need like a weird voltage, like a +18 or something.
No,
like
that was for core.
That's super easy with just like
For the main one. Yeah.
regular Meanwells.
No, that's 12 on the MOS RAMs. Let's see. Let me open up. Let's see. This one. Oh, let's power supply. Memory. On the B, the memory. Oops. That may help. Block diagram does not show power supplies. All right. I show how it works. Where's oh memory controller, but that's not the maintenance manual.
All right, now I can try and find some screws that'll work for that dang thing.
Power supply. Port expander, which we don't have. Maintenance manual, system description. Memory controller, DMA maintenance. Uh-oh. No
This is
schematic.
This is atrocious. Which one of you sucks the least?
Maintenance electrical drawings. That's got everything on it. Okay. Okay. IO gets ground and +5.
That's it?
That's it.
Sounds like it'd be. It
Others-
sounds like it's going to be very easy to do a meanwell upgrade for this thing.
Yeah.
I mean, the primary
Well-
5 meanwell's got to be chunky, but that's fine.
Yeah. Plus and minus, well, the 35 volt, the two 35 volt AC connections are there on the power supply, but I don't see them on the CPU anywhere. Wait a minute. Let me get to a different schematic. Oh, that's all there is.
Touch. Okay.
24K memory. Okay, that's schematic for that, but where? Oh, top jumpers for the memory boards. Front panel, there's that again.
That's less than ideal, but more ideal than it was. I guess we'll flip it over and these two back in.
Oh, if you could give me a part number for the memory chips that are used, that'll determine our power supplies too.
Oh yeah, depending on which what the data sheet says for them.
Yep.
All right. This is your last chance, power supply. If you don't do something exciting here, you're headed to the bin. And I'm talking exciting, like I want to see lights come on. No, of course not. Didn't do anything.
You're on the wrong side to look at the lights, though.
I was looking at them.
Oh, you were.
Yeah. Yeah.
Not
Nope.
so lucky. Nada.
Zip,
Oh,
zero,
wow.
and zilch.
I mean, if nothing else, nobody's going to be able to say we didn't try hard enough.
Yeah. After 3 weeks, yeah.
And it's just like, if we had the right schematics, it would be different. If we had the right schematics, I mean, we could definitely start hunting stuff down.
Oh, yeah.
But there's so many wild differences going on here that it's now not a repair project, it's a reverse engineering project.
Yep.
And it's reverse engineering broken equipment.
Yeah. And like the question then becomes like, why? You know, why do we want to reverse engineer this thing? Is it because we want to preserve it? And like, if it were the G15 or if it were the LGB21, I would say absolutely. We want to go through whatever effort is necessary to try and keep as much of this thing as original as possible. But it is a TI-980. They made a lot of them.
Not just that, the magic word is what you just said, possible. This is
Yeah.
becoming something that's not realistically possible anymore.
Well, so it's a balance, right? Like, you know, everything is possible with time and money. So you have to make a judgment call of what is worth the time and the money. And so we've spent the time on it, and we're realizing that we need to spend much more time on it. I don't think money's a big issue here, but I think probably to get this power supply going by only working on it once a week is a 6 month to a year long endeavor. Unless I step away, unless I do a whole lot of work off camera. Like, you know, unless I go, okay, there's no video this week, or I turn this into an actual video series on the main channel or something like that. And I go, let me just spend a week reverse engineering this thing, right? And that's a huge amount of effort for what gain? Like, what do we gain by keeping the original power supply in this thing? Aside from a healthy fear of ever turning it on.
Yeah.
So like it you know, it comes down to like, yeah, the 980 is kind of a rare machine nowadays, but I think it's a neat machine, but I don't necessarily think it's a special machine. Just like I don't think like a Data General Nova 1200 is a special machine. And when I say special, I don't mean like special as in what's special to me. I mean like special as in what's historically significant and should remain as close to its full original condition as possible. You know, is this a Ferrari 250 GT, or is this a Austin Healey Sprite?
Fuego.
Yeah. Well, I mean, it's still very cool. Like an Austin Healey Sprite is a very cool car, but it's not a Ferrari 250 GT. You know, it's not a 1963 Ferrari. You know, it's right. So nobody on earth is going to go, how dare you engine swap an Austin Healey Sprite, right?
I was going with Renault Fuego because it did kind of catch fire once.
Yeah, well, but the thing is that nobody is that a Renault Fuego wasn't necessarily considered a special car. Whereas like a Healey Sprite is considered a special car today even, but like nobody's going to lose their mind if you do an engine swap on a Healey Sprite, but people will like burn you at the stake if you do it on a Ferrari 250 GT, because a Ferrari is a special car. It's special for automotive history. And so the question is like for computing history, is the TI-980 special? I think it's special to me because I like the story behind it. I think it's funny that it was like a legitimate barn find. But as far as computing history goes, I feel it's a bit like the Centurion. It's just kind of a blip.
Well, I guess my contention is that even if it were something that were highly historically significant, the physically degraded parts of things, like that relay casing where the markings have literally evaporated with time, you can stare at that thing for the next 20 years and you're not going to be able to identify it. And if you can't identify it, there's nowhere for you to go.
Yeah, and that's just one part of this. Like every part of this thing is so rusty and gross like that. If you want to preserve a TI-980, this is not the example to do that with, right? All right, so let me get the part number for your memory here.
Yeah, this is the machine that we would fix with modern parts to use as a debugging aid for the showroom piece that somebody else finds later.
Yeah, like this is a toy. Like there's like nobody's gonna lose their mind over us, doing strange stuff with it and playing around with it. And I think having mean wells in it'll make the whole thing run a whole lot better. Oh man, I would love to tell you a part number, but here we go. P1103A. So that's our memory chips. Papa 1103 Alpha.
Okay. It's the same on the other board too?
Yeah, I think so. No, this board actually has different chips. These are MF8006. So Mike Foxtrot 8006. 3 zeros. 80006.
Okay. Oops. Not supposed to have a J in the word data sheet. Supposed to be an H.
Hey man, you can spell things however you want.
Oh yeah, that happened to us at work today. My boss and his wife were trying to do some stuff involving a certain airline, and they had received this code in their email that was Fox number, and spent most of yesterday and about half of today arguing with them over how this code not working, reset this password, reset that password, so on and so forth. It turned out that the code was F0X something or another, but their font and their emails renders capital O and 0 pixel identical.
Oh, jeez.
I hate fonts that do that, man.
Yeah.
The Intel P1103 DRAM is 16 volt.
16 volts. Okay.
That's a fun one. All right, so we're gonna have to. How are they getting that 16 volt though? Because our power supply wasn't generating 16.
It's supposed to be either 16.2 or 12, according to the B type power supply.
And yeah, it could very well be that the A revision runs at a lower voltage than the initial version too.
I wonder, do they have a regulator on the PCB here? I don't see one.
I'll be back in a minute.
I couldn't find the M8006 at all. MF.
Yeah, Mike Foxtrot 8006.
Do you see a manufacturer at all?
Oh, it's got two numbers. The second number is MF1103.
Oh,
1103.
Says that it's probably pin compatible with the other guy.
Yeah, that would make sense. Mitsubishi. Okay.
Yeah, the boards are slightly different. Looks like the same artwork, but they've got slightly different components laid out on them.
Yeah, those are 1K by 1, and they are the first commercially successful dynamic RAM chip.
Yep.
And they want 16 volts?
Yeah, 16 and a half. 16.2. Voltage drop, of course.
So I'm wondering what the power supply is supposed to output.
I would say 16.2, so you get 16 volts at the board or at the chips.
$16's a lot harder to find in Meanwell land.
Well, maybe you can push a 15.
Yeah, we can find a 15. But what is the, so like, do we have a 16.2 on the backplane? Coming out of the even with the one
It's
with the 980B?
pin 5 and 6 on the motherboard. They're on the CPU backplane. And that's coming straight from
Oh, I gotcha, yeah. So it's
70.
16.2 or 12, depending on probably which regulator
The
board
memory
you've got. Yeah.
Yeah.
So
Which memory
yeah.
you're using.
So we want +5 main, plus 16.2, -5. You want there's a +5 standby on there.
That's the battery, so don't worry about it.
So we don't need to worry about that. So we've got +5, -5, plus 16.2. Then we've got the +35 and -35 AC, but we're not sure if anything uses that. Then we've
I'll
got
check on the CPU boards, arithmetic units, and see if I can find anything there.
and then finally we've got the MP set, maybe M reset, maybe.
Memory reset. Oh, that is generated on the let's see, that's generated on the MEMOX board. I remember seeing that earlier.
It looks like it's actually just the -35 AC. Am I tracing that wrong?
Yeah, you must be, because it's coming from an open collector, shall we say, a single transistor driving it. It's negative true.
I mean, look at the backplane schematic. I swear that's going to the -35 AC directly. And then you've got E9, E10 as a jumper up to the MEMOX board.
Wait a minute. Let's see.
I wonder if there's such a thing as a 16-volt.
MEMOX board. Where is it? I saw it earlier. Oh, wait a minute. There it is. M reset is on the 5-volt power regulator board. First sheet, page 109. Oh no, wait a minute, 108. The lower left-hand corner.
Yeah, but look at page 85.
85. Okay. M reset.
Goes through pins 19 and 21, or 19 and 20.
19 and 21.
Yeah, 19 and 20, and then you can see it goes straight to -35 AC, straight off the transformer.
I'm seeing M reset on pins 24, 25, or 23, 24 on the motherboard, and it goes up to.
Oh,
pin
did they
60.
make a typo? Is that what I'm seeing? Because look at it. Follow 23 and 24. You've got M reset coming into the connector, and then pass through the connector out the bottom, and it says -35 VAC E7 on 23, 24.
On the voltage regulator, the 5-volt regulator board
No,
schematic.
no. On the very bottom of the power supply schematic.
Oh,
So you're looking at the power supply schematic with the three, page 85, right?
yes.
With the 3 edge connectors. Look at the bottommost edge connector, P2 XP2.
Right. XP2 is the CPU
Yeah.
backplane.
So look at what 23 and 24 is labeled as on the XP2 side.
M reset minus 35 volts. Wow.
I think that's a typo. I think we found a typo.
Yeah, it's a typo because E5 is M reset, and that's at 19 and 20,
Which is actually
goes
negative 35.
to negative 35.
Yeah, that's why I was saying that it looked like M reset was going to negative 35 directly. I was lost. The typo got me.
Yeah, well, yeah, just like the LC down on the right-hand side isn't really LC, it's sense ground.
Yeah, they did a wonderful job.
Are we having?
Well, these were all hand drawn.
Yeah.
No CAD involved. The only CAD that got involved at TI was in chip design and manufacture, not in stuff like this. That's all hand drawn.
So what is M reset, and do we need to worry about it?
I would just, for blanks and giggles, set a 555 timer if we need it.
Yeah, I mean, we
Or
can
even
build
a
something.
74, a 121 or a 123. A 121 would be good because you only need one. Just to make a pulse when the power comes up, it holds the memory reset low for a little bit before it lets it go. I'll try to find it on the memory schematics and see if I can find it. Since it's all handwritten, there is no such thing on PDFs of doing a text search.
Yeah.
Not this.
All right. So, I mean, honestly, it looks like we can get away with one big honkin' +5, a plus
Yeah.
15, and that's kind of, and a -5. So I just need 2 5-volt supplies and a +15 supply that maybe we can crank up to get close to +16.
Yeah. Those mean wells seem to be able to go at least a volt up.
Yeah.
And it's not as though it's this high current thing. So, you know, those MOS devices don't really need that much current for the 12 volts.
Yeah, I'll probably get a small 15-volt supply and a small -5, and then I'll probably get like a, oh man, I can't imagine it needing that much for the +5. Maybe a 20 amp +5 or something like that.
Well, let's see. Did we have it?
Yeah, does
I think
this
in the
thing actually
very
say what it?
front of the program, I think it does. +5, 30 amp.
Okay, so 30 amp.
Okay.
Oh, there it goes.
12, +12, 2 amps. Plus and minus 15.3 amps. I don't know where we had that.
Yeah, I don't remember
Let's see.
seeing the ±15 down there. It's not on that edge connector, so the computer doesn't care about it.
No, but it may be required for your I/O through the top connector on the I/O.
Yeah, but
How
how the
it gets there,
IOs?
I don't remember. I don't remember how it gets there.
I was gonna say, because there's no other connection from the power supply to IO in any which way. It has to go through
Yeah.
that edge connector. That's the only way that power leaves the system.
Plus and minus 15 would have to come from the plus and minus 35 or 33 or 35. So that's the only way it would happen there. Let's see. Address. Okay. Oh, wow. Every address line has to have 5 transistors, 2 diodes, and a bunch of capacitors to. Oh, no, wait a minute. I take that back. Wait a minute. CE5. Not the address lines. The address lines, let's see. Okay, address lines 7404s. So that doesn't need to be, that's the chip selects that. Ah, the chip select is a 12-volt line.
All right. So if I
Okay.
get like an LRS 350, I might need an LRS 450. LRS 350. No, 350 would be fine. That would be 60 amps. An LRS 350 is probably a little overkill.
Overkill, but that's okay. It's always good to have plenty.
Well, the LRS 350 has a fan built in. The LRS 200 is passively cooled.
Oh, yeah.
And the 200 is a 40 amp supply. So I'll probably go for the 200 because I'll probably put the original fan back on the back, because the original fan has to go back on the back because it pulls cooling air across the
Yes.
cards, then through the power supply.
Right.
So I don't need a power supply with a cooling fan built in. It's better to have one that's kind of wide open.
Do you have the bottom panel for the whole processor, the whole computer?
Yeah, I got all the panels around here somewhere.
Okay. Because
Yeah, so
that keeps airflow through the cards.
and then an LRS 75, I think, is a real small guy. Yeah, and then I can get a couple LRS 75s for the 15. That would be 15 volts at 5 amps. And then I get another one at 5 volts, 14 amps for our negative 5 volts. That's overkill. But the LRS 75s are cheap and small.
All right.
Yeah. And then I could fit all 3 of those in there with plenty of room to spare. Yeah, so one LRS 200 and then 2 LRS 75s. And that gets us +5, -5, +15. I don't know why they're listing a -15, but
-15.
Well,
Oh,
they got-
plus and minus 15.
yeah, that ±
Yeah.
15 there.
Yeah, but if you look at the motherboard,
There's no 15 on it
there's no 15 on it. Yeah.
at all. There's the plus and minus 35 AC, but I have no idea what that could be used for.
Well, it could be the AC for a clock, but generally with TTL, all you need is the 9 volts AC going through an optical isolator, and boom, you've got yourself a stinking 60 hertz clock.
Yeah. Z, I don't know if it's going to be 15 volt may not be enough, but we're gonna adjust it up to get it close enough, hopefully. Otherwise, we got to try and hunt down a proper 16 volt power supply, which might be more of a pain in the butt. So we'll start with a 15 and see if we can get away with it.
May be able to bodge the Meanwell a little bit to push it if we have to, but Meanwells are usually pretty good about going out, a volt or so above.
Wait a
or
minute.
below.
Do Meanwells have a zero reference input?
Zero reference?
You know how some power supplies are designed to be up or down a certain amount of voltage from a reference point?
That's what the pot's for inside.
All right, no, I think we'll be all right. The LRS 75-15 in the data sheet for it says the output of voltage adjustment range is 13.5 to 18 volts.
Oh, okay, that's fine then. I was going to say, if it is hardwired for 15, you could feed the reference 1 volt and you would get 16 above ground.
Yeah, you don't really need to do that.
No, it looks like we're going to be able to adjust it to 16 volts just fine. Yeah, so I just need to get two LRS 75s, 75-15 to 75.5, and then an LRS 200.5, and that'll get us up and going.
Just with no load, set it to 16, and when you get the cards plugged in, set it to 16.2.
Yeah, once we load it up, we'll just readjust it.
Yep.
All right, that's what we'll do next week. I'm all right with that.
I'm still looking for a memory reset.
Yeah, well, we got a week to figure that one out.
Yeah.
All right, let me shut this guy down here. It's well beyond my bedtime.
Yeah.
Oh, yeah, especially because you got chores in the morning.
Yeah, the bunny definitely does not let me sleep in.
Oh.
She was making a racket this morning at like 7 a.m. So, yeah.
I'm surprised the cat doesn't either.
Yeah. All right, Twitch land. We'll see y'all next week, hopefully. Take it easy. Thanks for joining.